Part 2, identifying independent and dependent variables. I want you guys to be able to look at a scientific question and go, that's the independent variable and that's the dependent variable. So let's look at some examples. How does the amount of sunlight affect the amount of plant growth? So first I'm going to underline two variables, amount of sunlight and amount of plant growth. Those are two things that can change. Which one's the independent variable and which one's the dependent variable? Well, my strategy here is I'm going to think about what's the cause and what's the effect. It just so happens that the cause is the sunlight, or the amount of sunlight, and the effect is the amount of plant growth. You could write amount of plant growth or amount of sunlight. That's perfectly reasonable. You can even write, I don't know, the units. Maybe you're measuring the plant growth in centimeters. So I'm going to add the units to my variable. But in any case, we have a structure here. How does the IV affect the DV? The cause and effect. Another easy example. How does the brand of toothpaste affect the whiteness of your teeth? Again, I'm going to underline the two variables, brand of toothpaste and whiteness of your teeth. So which one's the cause and which one's the effect? Well, the effect, hopefully, is that your teeth get whiter if you use a different type of toothpaste. So we know that our effect is the brand of toothpaste. Or sorry, yeah, I mixed it up here. The effect is the whiteness of your teeth. And that is influenced or dependent on the brand of toothpaste. And I'm just writing brand instead of brand of toothpaste, just because I'm lazy. I don't want to fill in that whole sentence there. Okay, how does the amount of time spent studying affect my grade in my physics class? So let's again underline amount of time spent studying affect my grade in my physics class. We have two variables. The effect. Hopefully, if you spend more time studying, your grade is going to go up. So your grade is the effect. And the amount of time you spend studying, that's the cause. So time spent studying, measured in, I don't know, hours. Days for some of you. No, just kidding. Time spent studying affect the grade. So you see, we have this structure. How does the independent variable affect the dependent variable? We got some harder examples. Okay, now these ones, excuse me, these ones you got to kind of think about a little bit more. An education scientist wants to see if students that live further away from their high school have lower test scores. Okay, so now let's start to break this down as an experiment. So what they're going to do is they're going to probably look at students, some that live really far away, some that live really close to their high school, and then they're going to look at their test scores and see, oh wait, if they live really far, does that mean that their test scores are lower? Does that mean that their test scores are higher? So we're going to do the same thing where we think about what's the cause and the effect. So the effect is their test scores. So because dependent variable represents the effect, let's just write that in first. Their test scores. And the independent variable in this example is how far away they are from their high school. So I could write how far away they are from their high school, but instead I'll just use a nice physics variable, which we call distance. Their distance from school. And I don't know what the units would be, maybe measured in miles. MI. That's not a SI unit or a proper physics unit, but that's what we use in America. So these harder examples, I want you to just envision it as a science experiment and think about what is this experimenter going to actually test or do. All right, next hard example. You test a new shampoo that supposedly makes your hair soft. You want to know how much of the shampoo will generate an effect. Okay, so you want your hair to be soft, and that's going to be the effect. So how do we say this? You want your hair, it makes your hair soft. That's the downstream effect. So we know that that's the dependent variable. So what I'm going to do, I'm going to think about what would that be. So makes my hair soft? I can't really write that. So I'm going to turn that phrase into a variable. So softness. The softness of my hair. I don't know how you're going to measure the softness of your hair, but hopefully that is the effect of the shampoo. Now, are they using different brands of shampoo in this case? No, they're looking at how much of the shampoo will generate effect. And I could write here in this box, I could write how much shampoo, but I'm gonna stick to a more sciencey thing and say amount of shampoo. An even better one would be the volume of shampoo. That would probably be like an even more sciencey way of saying that independent variable. Anyways, that's how that one goes. Now, here we have the last one of our harder examples. But what's nice is that this hard example might actually be the easiest one. A scientist examines the following data set to determine if there is a relationship between the x variable and the y variable. So let's look at it. Our x variable is here, our y variable is here. That's how we set up these data charts. And in this case, we have temperature and we have forest growth. So the secret is that your independent variable is most always graphed on the x-axis, and your dependent variable is almost always graphed on your y-axis. Excuse me, so we don't even have to think about cause and effect in this one. We can just write it in. Temperature and forest growth. Looking at this data set, it looks like as the temperature warms up, the forest grow. There's more sprouting seeds, and that still makes sense. Here's the effect, and here's the cause. The number of sprouting seeds is increased by the temperature. So we still have the cause and effect thing going on, but it's just nice. It's already in a data set for us, and so we just look at what's x and what's y. What's the independent variable? What's the dependent variable? Okay, so let's just go over these strategies. Identify what the variables are before picking the independent variable. Before picking the IV and DV, that's when we just underlined those variables. Identify the cause and the effect. Turn the description into a scientific question in standard format. For example, with this one, you could think about how does temperature affect forest growth? How does temperature affect forest growth? So that would be one way that you could figure it out. So that's that standard format. So how does the IV affect the DV? How does my IV affect my DV? Independent variable, dependent variable. The independent variable is graphed on the x-axis, and the dependent variable is graphed on the y-axis. That's another strategy that you can use for thinking about identifying independent and dependent variables.